All right, guys, welcome to our first podcast at the Waterproofing Shop, presented by Forspec. Today is our first podcast, and we were lucky enough to have Rob from our reputable waterproofing training facility from Forspec. And we're going to be running about the do's and don'ts, what we've seen on the job sites, and how to prepare for things. And the first topic today is primers and priming. One of the biggest issues on the industry at the moment, Rob.
Yes, well, as I say, may I just say, James, thanks for having me here today. Just to kick off, mate, it is a crime not to prime. That's what I found. It's a crime not to prime. Mate, it has to go, isn't it? It has to. Because people are just going willy-nilly, thinking that it's all right to do this and it's got to do that. It's not, okay? We need to prime. We have to know when to prime, what to prime with, and how to actually prime. And these are the situations and the issues that we're actually having out there in the industry.
Yeah. We've seen so many problems lately, Rob, especially on external roof areas or external wet areas, exposed. Just the whole heap of problems, bubbling, gassing, pinholing, delamination, wrong primers with wrong membrane, just guessing what goes with what. And I think just need to bring it up in the topic, how to address it, compatibility, all the things got to do with primer.
Yeah, well, I mean, like as you've just touched on there, James, you know, like the failures in the waterproofing industry, or the well-known failures that have been in the waterproofing industry for years, have been moisture in the substrate, inadequate surface preparation, incompatible transitional changes, and now we're looking at how we're terminating drainage provisions, and a big thing now is compatibility with the actual systems or the products that we're using. So that comes straight away from the actual substrate through to the primer, then through to the coatings. So if one of them are out of whack, there's a big chance that we're going to have those problems that you just mentioned.
Yeah.
So that's what we're up against. How do we overcome it?
I think, tell you a story. Customer started off a job, roof was about 800 square meters. Got to the roof, done a pre-inspection, inadequate falls, didn't achieve the 1 in 100. The builder started grinding 2-4 to get adequate falls, done self-leveling. Then they went and inspected the roof. They were ready to started raining. They waited for the rain to pass. 2 days later in the sun was out, dried up the roof. They didn't do a moisture test, number one. They just relied on the 2 sunny days. They got their primer on the roof. They're using a EP250, which is an epoxy primer, moisture barrier and a vapor barrier. They started mixing the part A with the part B. They didn't wet the substrate, they didn't add water in the first coat. So anyway, they rolled out the first coat. They finished the job. They started maybe at 8, finished at about 3. They rolled out the first coat. They didn't inspect the first coat. They just kept rolling. Came back the next morning at 7 to do the second coat. They didn't inspect the first coat to see if there was any pinholes or anything. They rolled out the second coat again with no water. They finished the second coat. They came back the next day to do the membrane. They'd done the membrane. They'd done the second coat of membrane. They got to the top coat. When they got to the top coat, pinholes everywhere, Rob. Disaster.
Yeah.
So we went out to the job. We did on-site testing. We cut out some pieces. The pinholes have gone straight through to the concrete substrate, and you can see the actual the pores in the concrete, which is like a little pinhole. That's transferred all the way through the membrane.
Yeah.
They're in a situation now, Rob.
Well, look, it's, follow the manufacturer's recommendations. The manufacturer's recommendations with, you said the EP250 was that with your first coat, you want to mix, a percentage of water in it. The thing about substrates is, what is their moisture content? That should have been checked, because we want the substrate to be able to absorb rather than repel. Right? So if that substrate had any large volume of moisture content in it, when the actual neat, because it wasn't watered down, when the actual neat 250 went on it, rather than penetrating the surface, it could have actually sat on the surface and being repelled because you're putting wet on wet. Okay, so it's like if you go along and you put a mat on a wet surface, you suffocate that area, you're going to draw the moisture to the surface. Well, the same thing can happen with a membrane, especially with your EP250 because of its molecular structure. It's a layer, right? And then as it's trying to dry, you've got a layer of coverage over a substrate that you think might be dry, but if there's any moisture, it's going to bring that to the surface because of the high moisture content. So that's first principle. Test your moisture content on your substrate.
But if it's a moisture barrier and you're doing the minimum of 2 coats to get that moisture barrier, do you still need to do a moisture meter test?
Well, yeah, because what it actually is it's your first stage of application in your like your preparation process is to remove all dust, grime, any contaminants that might be on the surface. In this case, it was ground.
It was ground and leveling.
Right. So it's, no, but we're just talking about the substrate. It's been ground, so it's opened the pores to receive. Right. Unfortunately, the first thing it's received is rain overnight. Right. And then they've waited all this time without actually testing the moisture content of it. What screed was used? Was it just a normal sand cement, or was it one of the engineered? Because they got a tighter molecular structure. One is more dense than the other. So where it might dry, leave it in the sun for 48 hours. If it's more of a denser product, it'll take longer to dry. Right, because it's not being absorbed out. And that's the thing that we need. It's very strange. We actually have to dry a substrate to then wet it down to apply the product. Right? It's like.
So explain that, Rob.
It's like that.
So what's happening to the primer, the EP250? If I put it on a substrate that's over 5% moisture, what's happening in that situation?
Well, it's not that anything might be happening. It's just that there's a greater chance of it repelling rather than absorbing. We're the ones that are in control of the application, okay? And that's why we need the dry substrate down to 4%. I tell you, if you get a 4% moisture content substrate out there, let me know. Have a party. But basically, what it is that then we get to control it, okay? If it's greater than that, it's got more moisture in it, and we're putting wet on wet. Right? When it's dry, when we dry it down, we actually have to mist it down, like when we render. How do we render? We come up to a brick wall and we'll mist it down so that when we put the render on it, at that interface, it actually absorbs the material.
Yeah, sucks it in.
It's like a key. It's like a key. And that's what we require when we're doing with the EP250. We have to change that molecular structure of it, right? Because as I said, it's thicker than a paint when you put it on. It's not a paint, it's a membrane.
It's a high viscous.
It's a high viscous membrane. So what we're actually doing is we're misting down the substrate, we're mixing water, a percentage of water in the first coat so that we get penetration. And the way that we're doing that is by controlling the absorption of the substrate, as well as changing the viscosity of the EP250.
Of the product,
Right. That's key. That's your first coat. And that's the way that it's got to be with the EP250 or the water-based epoxies that are out there. Right. Your second coat can go on needle with a lower percentage just so that it's easily spread. But that's when you start to achieve your wet film thicknesses that lead to your dry film thicknesses, and you get your vapor barrier.
I think as well, Rob, when you water down that coat, it's proven in the past that when you water down that first coat, say 20% example, it's filling in all those pinholes, all those divots, all that porous substrate better than no water would.
Yeah, well, what it's actually doing, it's saturating the material or whatever the makeup is of the screed or the concrete or the substrate, so that then that material can no longer absorb. Okay, it's like when we do a brick injection, right? We inject the brick so the capillary won't suck through the brick anymore. Right. The voids and all that.
You're flooding that area.
All the voids and that are still there. Right, but they won't soak anymore. Right, because they won't soak, they're not going to outgas as well because we've sealed it. Right, that's what your first coat's about. Right?
I think also everyone forgets when they water down that coat, penetrates the substrate, then you do your second or third coat, that's when the moisture barrier is working because it's now penetrated the substrate instead of the moisture coming to the surface, then trying to break through.
Yeah, well.
So you're stopping it inside the substrate first.
Well, I mean, you've got to understand too that, you know, what is a primer? What's a primer's purpose?
What is a primer, Rob?
Well,
We should have started with that.
Well, I mean, there's plenty of primers out there, but I mean, like, the primer is a material that assists us with the adhesion of following coatings. So, like, your primer, then it's an adhesive enhancer, and it's not that it's going to make it, you know, more stickable or anything like that. What it actually does is it then allows the following coatings, you know, to work in the way that they need to work. All right, they will tie in. That's why we want compatibility too with primers. Mm-hmm. So if we put a primer on a surface, it seals the surface, right? It stops the suction of the surface, and then the following coat goes over the top of it. See, primers are very tricky too. I mean, like, out of all the materials, you really need to be looking at the recoat window of primers.
It's definitely the problem area that everyone's getting wrong.
Recoat windows around primers is key.
For sure.
I mean, you know, and some of these things, if you don't get it right, and molecular structure just locks off, you're coming back tomorrow and you're grinding the thing off. You know, you can't put another primer on it because it's locked off. It's not going to penetrate into it, anything like that. So all you've got is you've got a coating, and then you've got another layer going over it. You may as well make a ham sandwich, you know. That's how it is, you know. It's like a Sara Lee cheesecake. But that's what it just.
So
it's just
what happens if they've done their first coat, they come back to do their second coat, start training a couple of days. So now they're on their third or fourth day, they still got to do their second coat. Does that second coat now work on that first coat?
No.
So what do you do in that situation?
Well, in the case of using the EP250s and the water-based epoxies that have those, you know, attributes to what they can do, you actually have to grind that off. You'd have to do some tests.
Sacrificial grind.
Yeah, no, you'd have to do some tests to see if you've got any adhesion issues, which you're going to have, and then basically you're going to have to grind it off. And the thing about it is that if you've done your first coat properly, where you're lucky with this 800 square metre roof, it doesn't sound like it's been done properly because they've gone on neat, so it actually really hasn't penetrated that much. But if you've done it properly and the rains come, you're looking at grinding off about 2 to 3 mil, because that's how far it's penetrated. And that's where the water-based epoxy has gone to. So, you know, as I said, they're key. You know, part of planning and organising is having a look at the weather. You know, we've all got phones.
Yeah.
You know, have a look at the phone. You know, and the good thing about that is that you can actually look at the phone in the area that you're in, and it's going to tell you if it's going to rain there tomorrow.
At what time?
Yeah, well, you know, around about there. You know, we're looking at, you know, 30% rain here, where in other parts of Sydney it might not even be raining. So, you know, there's things like that you've got to do, especially around your installation processes, because, you know, that first part of it's key.
On the same roof, Rob, when we were doing all our cutout samples, check the pinholes, as we were ripping up the membrane, there was a layer of surface concrete coming up with the membrane, like maybe a 2 or 3 mil layer of concrete. So the primer adhered to the substrate, but as we're pulling off the membrane, the concrete is coming up with it.
Yeah.
So in that case, the builder did grind the roof. It's a must to high pressure wash to get all that latence off, that dust, that loose cement, that loose concrete. Because if you don't, you don't know what's on that surface. So if the boys just go and get the blower out, blow the dust, maybe vacuum. Don't think so. Who's going to vacuum 800 square metre roof? They just get the blower, epoxy prime straight away. Then they've got all these issues about debonding, concrete coming up, pinholes. So I think the biggest issue at the point is high pressure washing as well. If you've got time. But the problem is we don't have time. Builder doesn't allow us. We're on a tight schedule. All the bullshit that comes with it.
Okay, so what are we up against now in the industry, in the NCC and the like? You know, it's going to be falls in the substrate. We're getting away. Silica is a big issue in the industry at the moment. So, you know, if you're going to dry grind, you have to have all the dust suppression equipment to do it right. As I said, it's a massive thing. And on the other side, and as you mentioned, you know, if we're going to pressure wash, what's the condition of the surface that we're pressure washing? So you're telling me that it was screeded. What was it screeded with? Was it compacted? and it sounds like it wasn't, because if it's bringing up where the actual membrane's actually saturated or the primer's saturated and being pulled up with the coating, it actually hasn't been compacted well enough.
Who knows what happened on the pour day? Rain, too much heat, too hot, MPA strength, too high, high slump, low slump.
This is why we carry out tests of our materials in the stages. You know, this is why we need hold points to find out, well, okay, let's have a look at this. Before we go ahead, let's look at this. Let's run some tests. Yeah, it's good to go. Next stage, hold point, have a look. You would have been able to spot those pinholes early on.
Yeah.
You know, you would have found those early on. You would have also found, if you look closely, that in your actual membrane, when it was actually curing, there would have been like lines going through it, like a street map, because of how it was trying to like penetrate, but not being able to penetrate because of the moisture in the surface, right? And then these things is just how your epoxy was drying on the surface. So you know, it's shrinkage when it's shrinking, because what we say, it's 53% solid. Yeah,
about that,
Yeah, so, and you're going on thick, so it's got that percentage of shrinkage. So if you're going on at, 300 micron, which is, the required thickness per layer, and it's going to shrink half of that.
I think people just need to look at that primer coat. So if they've done their 2 coats of primer, just spend an hour or two going around checking for these pinholes. That's number one issue. Because if you're putting a membrane on top of a pinhole, that membrane is just going to pinhole. And then what they do is, they've done their 2 coats of membrane, then they go, oh, we've got pinholes. So they try to put another coat of membrane on it, with xylene down or thin down with water, whatever they're using, polyurethane or water base. And then that is also pinholing. Then they're like stuck. So they try now a primer coat on top of the pinhole. That primer coat's now pinholed. Now they've got like 6 layers of pinholes.
Yeah.
When the only solution is either to grind it, which is the right way, or to fill it up with sausage. So you're going to fill up the whole roof with sausage, which is the viable way at the time, because no one's going to grind the roof again before they put their top coat.
May as well coat it with sausage.
Yeah. They do. Some of the roofs, they get done with sausage.
Yeah, nasty. And that's, as I said, that's the problem. Like, where's your flood coat, right? So let's get away from priming for just a minute and look at some other coatings and how they work. Let's look at sealers, because we're talking about sealing a substrate, not necessarily priming for another coating. So we're not looking at that in adhesion enhancing. What we're actually looking at is how these things get sealed. Right, so when we come along with these sealers and we actually flood them, we don't leave it there in ponds. Right? We actually drag that off because of the way that the sealer will dry. But we actually use the material there to actually saturate where it needs to saturate and allow the substrate to draw in what it needs to draw in. And we then roll off or clean off the excess. Right? I'm not saying that we need to do that with the EP250, but we have to actually look at that way of going about things, and it's key that we actually change the viscosity on it for that first coat to actually penetrate in and sort of like assist it in being able to do that, so that your first coat, rather than skimp on it and stuff like that, we can actually give it more of a flood coat in the action of it, and then like let it absorb where it needs to absorb, but still roll it out neatly, because the same thing too is with primers. You don't want to have too thick of a coating, because that can delaminate interlayer. All right, so that's drying from the substrate and drying from the atmosphere, and then you've got this interlayer that's still wet.
Yeah, a lot of people think they do the epoxy primer and they want to roll it out like a water-based membrane. They want to see the ripple marks
that's not
that they get. Yeah, so
that's not going to happen.
It's a completely different situation.
We're looking at, and I don't like saying anything waterproofing, but we're basically looking at a paint coating. And especially with that first coating, we've got to give it the opportunity to penetrate into the surface, and we've got to assist it in any way possible so that it does penetrate into that surface, because that's what it is. We're after penetration.
What has worked in this situation many times, people don't like doing it, is 3-coat epoxy primer. First coat 20% water.
Yeah.
Second coat 10% water.
Yeah.
and the third coat either no water or 5% water.
Yeah.
To the total DFT of 300 micron.
Yeah.
We know that works. Whether you guys do it or not, they do it. I don't know. But then they complain about time, money. But at the end of the day, their money spent, which is very minimal. They'll probably use an extra 5% of material because they're watering down the coats.
Yeah.
They're getting a higher square meter coverage.
Yeah.
But then they get to the end result and they've got no pinholes.
Yeah.
So it's either you save your 5% cost at the beginning, or you wear it at the end with like an extra 50 to 60% cost. And that's doing sausage, that's not even grinding.
Well, yeah, I mean, like, let's look at the 800 square metres that you're having trouble with now.
Yeah.
Where was the money best spent? Because to remove it, right, and if half of it's, say out of the 800 square metres, say 400 metres is all right, and you've got to remove 400 metres, you've still got to remove 400 metres.
Yeah, you're down 15 grand in grinding.
Well, there you go.
Yeah.
So where did you end up paying the cost anyway?
Yeah.
Right. Whereas what you're saying is like your spread rates lengthen by the addition of water. We need the addition of water. It's actually part of the process, so we actually need that. So it's not as if we're going to go without it because they've gone without it and the problem that they've had. So add water. It says add water, so add water. Don't necessarily worry about your spread rate. Just make sure that you're getting the coverage of saturation, so that it's absorbing through into that first coat.
I think everyone's just trying to follow the TDS, but the TDS is strictly for basically a perfect condition substrate. When the TDS is written, it's written for a substrate that doesn't have defects, a substrate that's not grinded.
But it was a new substrate.
Yeah, but
no, you said it was a new substrate. That was Falls created.
Yeah.
So it was a new substrate.
But grinded.
Yeah. Well, they had to remove the.
Had to remove the grind, yeah.
Yeah, and all grinding does is open up the pores of the surface to be able to receive coatings. So all those things were done so that it could receive the first coating of primer, which sounds like it wasn't applied correctly. And if that one's not applied correctly, as you said, the second one, same thing's going to happen. Third one,
it's going to transfer through.
Just going to keep going, keep going.
Until they sausage it.
Well, if they sausage it, go up there and have a barbecue. Yeah, no, as I said, look, it's key. What do we say? Moisture in substrate, surface preparation. They're your first 2 points.
Yeah.
It's a crime, not the prime, but...
Ring the manufacturer.
Well...
Ask him what the situation, what you got. That's just the biggest question. No one wants to ring. No one wants to ask the question.
Everyone's got a phone.
Everyone thinks they know what they're doing because...
Everyone's got a phone.
Pinholes only became apparent maybe 6 years ago, 7 years ago.
Well,
they were always there, but people never used to look for them. So people never saw them. But now everyone knows what a pinhole is. Everyone's seeing them. Everyone's defecting them. Yeah. So you go on a roof that was done 12 years ago, I guarantee there's pinholes everywhere.
I think they've been around longer than 6 years.
Yeah, for sure.
Those pinholes. Yeah. Like I said, the moisture, look at the moisture and that surface preparation. The first 2 steps of having a good system or a reputable system that's going to give you longevity and will last. How many days has this thing been up?
The roof?
Yeah, this job. How many days?
It's been about a month and a half now.
About a month and a half.
Yeah, a month and a half, no sausage.
Cool, no sausage
yet.
No sausage yet. So there you got 800 square metres, you just paid for a brand new roof and you got a month and a half out of it.
Yeah.
Good job.
We do have alternative solution to the EP250, which is a new 1-component polyurethane primer, MB200. Right. It's also a moisture barrier at 2 coats. We bought this out for this reason, created this product. Reason being is a PU primer will always, in my opinion, will always penetrate the surface better than epoxy primer would. Right. Epoxy primer without water, not epoxy primer with water.
Yeah. You're looking at the molecular structure of the material.
Correct.
Because solvents are thinner than water.
Yeah.
So it's going to penetrate. Yeah.
So once they've applied 2 coats of this moisture barrier, this PU primer, MB200, it's filled in all those little pinholes, all those divots better than the epoxy primer would at 2 coats. And we're getting a lot, at least 90% less pinholing on a grinded roof compared to the epoxy primer that got used incorrectly. We're not saying it's better than an epoxy primer used correctly, but in a situation where it's used incorrectly, MB200 will perform better.
Horses for courses. I mean, you know, no movement, casted areas, why not use a water-based epoxy? You know, but if there's movement, use the polyurethane. So the epoxy is rigid, polyurethane is flexible, or stretchable, has an elongation. It doesn't have to be much, but just that little bit of is enough.
That's crazing, crazing issue.
It's not necessarily, it accommodates whatever, like, especially on new builds, you know, you have settlement, and that can compensate for that settlement as well, you know. Think about that, you know, once again, you look at the recoat in regards to that. You know, can I put that down at a stage like during settlement as a protection as well, and then come later, or does it have to be once again activator or ground to put the next layer on and stuff like that? So yeah, I mean, like if it's got a recoat window there that can be extended, you know, maybe that's something there that they can look at as well with that primer.
Activations are good.
Well,
what do you mean by activator?
Well, activators basically you'll come along and you'll have sort of like not necessarily a cured surface, but like reasonably dry or dry, and then you come along with some type of solvent wipe or something that can actually activate the surface and wipe it over, and it will give it a bit of reactivation of the material, and then you just go over the top of it.
I think that's happening a lot on exposed areas due to the rain issue. They're getting their primers done, they're getting their, let's talk about PU, their PU coats done. Then it rains for 3 days, 4 days, a week. They can't get to the roof, dust has settled on it, plasticizers have risen. Then they come to do their top coat. What happens in that period where from end of the second coat to start of the top coat?
Yeah, well, you got that interface too. That has to be clean.
Yeah.
You know, it has to be clean. As I said, if you can activate, you can activate. I'm aware of there's some products out there that you can put one coat down, leave it for 30 days, and come over and use another product over it. If you want to use the same, they said you can go out to 90 days. I said, 90 days, that's 3 months. They said, yeah, 3 months you can go over
with no cleaning, no nothing?
Oh, you clean it, you've got to clean it. Yeah. Otherwise, we're just sticking to the dust.
Yeah.
But yeah, just give it a wipe and away you go. 90 days. And I went, oh, okay. But they're those industrial coatings and stuff like that. I've found that with, you know, you play around with the membranes and the like over the years, and this is the next thing that they're looking into when they're going to run these pull-off tests and stuff like that with these water-based polyurethanes. Polyurethane's an oil.
Yeah.
All right, putting oil in water doesn't mix well. You know, it'll separate out in time. It's like when you drive down the street. You know, I always say, you know, what's heavier, water or oil? What do you think? Water or oil? What's heavier? And so many people say oil. So many people say oil. I say what?
Had to think twice, eh?
Yeah, I know. Yeah. So many people think that it's oil, but you know, the oil rises. It's the same thing. You open up a bucket of membrane, the oil, it's separated. So you have to
sitting on the top, yeah.
You have to mix that through.
Yeah.
Right? And it's the same thing even with a water base. If you don't use the whole bucket overnight, like when you open a bucket, you tip it out or whatever, or you mix it. It's wise to mix it, tip it out.
That's another thing. They get to the roof, they open up all their drums. There's no mixing of the drums.
Yeah, straight out.
It's just straight.
Yeah, straight out. So
the resin is sitting on the bottom.
Yeah, you got a
xylene sitting on the top.
Separation line and stuff like that. But that's the thing too. So the thing about how you like the more polyurethane that they put in these things, you used to be able to wipe over it with a so you'd clean it like water base. You'd clean it with water, soapy water, clean it off, and then you get a half mix of acetone and water, and just wipe it over it, and it would activate it.
Yeah.
You could make it sticky, and then you could put a coat on it. Right? They started putting more polyurethane in it. That was harder. That didn't exist. So then you had to look at the nasties. The nasties are the xylenes.
Xylene, yeah.
You know.
Had fun time with xylene.
Yeah, look, and look, we're getting off topic here, but I mean, even some of the primers, you know, they could be activated with the xylene, but only within 9 to 12 hours.
Yeah, if you're lucky,
Yeah.
24 maybe. If
Yeah,
you're lucky.
No, yeah. Well, you've got
What's
your,
the-
you've
what's
got your
the-
700 here,
Yeah,
right?
it hardens too much
Yeah, I know.
for
So-
it to sit on top.
That's right.
Yeah.
So and those are the things, you know. If you're outside the Recoat window, you're grinding it.
Yeah.
You know, then they see, 6 hours.
When you say grinding, you're talking about sacrificial grind or full grind?
No, you got to grind it off
Yeah.
because you're not the molecular structure of the coating is locked off, so nothing's going to penetrate it. It's just going to stick to it,
Yeah.
right? And these things aren't non-porous primers, non-porous surface primers. They're actually penetrative
Yeah,
primers.
they're porous.
Yeah, so they need a porous surface, or so that they actually penetrate. Otherwise, you just come along with some type of adhesion.
Yeah.
So basically, if you failed and you're outside a Recoat window, and these things need to be ground off, and you don't want to grind it off, you then got a non-porous surface. So then you've got to then look at non-porous primers. And are you going to get penetration? No, but you're looking at something that's got great adhesion. And that's another,
That's where
set of
epoxy primer
terms as well.
would work.
Not necessarily after it's been, if you're going on a substrate, because the epoxy primer, albeit it's compatible with a lot of things, it still needs to be able to key into whatever it's going into. Right? Otherwise, it's just a layer that will actually sit on something. So it actually has penetration. It might not seem like it, but it has slight penetration into, like, it'll go onto a coating, it'll go onto a water-based coating. They say it's the best intermediate layer in regards to building materials and coatings.
Yeah.
Is a water-based epoxy. But once again, when do we use it? How do we use it?
Bring the manufacturer.
Yeah, well, that's what those people on the roof didn't do.
They rang us at the end.
They rang it
They rang us at the end.
Yeah.
How do we fix it?
Yeah.
You remember it's not working.
It's all over for us here, James. Know anyone that wants to buy a building?